This begins our lectures for section 3.1. In this section, we're going to be finding the definitions for solutions satisfying a solution set. We're going to know what a graph of an equation is. We're going to graph a function, a linear function, in the form y equals mx plus b. We're going to know what b is as the y-intercept, and we're going to learn about the rule of fours in equations. So we're going to start out with some definitions. We're first of all going to talk about an equation. An equation is the equality of two expressions, and an equation has an equal sign. An equation has a solution that makes the truth value of the statement true. The solution is said to satisfy the equation, give it a truth value of true. The models that we discussed in section 1.3 and 1.4, those were lines. And these lines can be described by an equation, and that equation is called a linear equation in two variables. And that's what this chapter is about, the linear equation in two variables. We're going to start out with our linear equation in two variables in slope-intercept form. Now, your book doesn't refer to it as slope-intercept form, but I want to introduce that right up front. With these linear equations in two variables, what we have are equations that are of the form y equals mx plus b, where y is our dependent and x is our independent variable. And as we input x's, we get outputs of y's. M and b are constants, and m, which we call a numeric coefficient for x, that's something called our slope. We'll learn a little bit more about that in section 3. And b, that is just a constant, but it's a special constant. It's called our y-intercept. And it's our y-intercept because when we put in values of x that is equal to 0, we see that 0 times anything is 0 and then plus the b. So we get x's that are 0 and y's that are a number, which we know from chapter 1 was a y-intercept. So that's why that b is the y-intercept. So what we need to understand is that an equation such as y equals mx plus b is going to be graphed as a straight line. So if I look at any straight line here, let's go over here to a different page, and I'm just going to say, okay, let's just put this line on this page, and then I'm going to put it in a coordinate system just like this. Okay, and in this coordinate system, this line we know we can take from the x-axis and we can go up to the model, and then we can go across here, and that gives us a y. So this point right here can be represented by some x and some y. And as it turns out, you can go all the way along this x-axis, all the way to infinity, and you can come up here and meet this linear model and come across here and find a y. Same thing coming from this side, right? We could come down and meet the model and find the y that goes with it, and all the way to infinity this way. The same is actually true of the y's, right? We learned that before. We can come from the y-axis, come over to the model, and find the x's. So what that really tells us is that every single x is going to be part of one of these solutions eventually, and every single y is going to be a part of the solutions. So for every non-vertical line, every x will be have one value of y associated with it. And all these are solutions. They're ordered pairs of the form xy that satisfy the equation. Remember, satisfy just means give a truth value of true. And those ordered pairs form the solution set, the set of all ordered pairs that are on this linear model. This linear equation has all these ordered pairs. And this line is a way of visualizing all the ordered pairs. And an equation like y equals mx plus b is another way of doing those. And those are just two of the four ways. Those are the two that show all the solutions. But we can show some of the solutions with a table. We've seen that already. And then we can also use the words to describe the rule so that we could get particular x's and y's. So with all this kind of summarized, now we're going to go on to our next lecture. And we're going to learn how we can find specific values of x's and y's and put them into our table based upon one of these linear models. And then from there, we're going to go back to graphing and plotting the linear equation and doing what we were doing in chapter 1.